Okay, last two videos of our basic derivative rules homework, and we're gonna read these together. I haven't read these yet, so we can decipher them together. We want to find values a and b, so we want to find two values. Okay, for this function, we don't even have the full function, but we know that when we plug in h of 1 equals 0, when we plug in 1 into our original function and get 0, and we plug in 1 into our derivative, h prime of 1 equals 4. So let's try to decipher this. This is interesting. I like the idea of having a little bit of a challenge. So when we plug in 1 instead of x, we're going to get 0. So let's try that. So 0 is our h of x. That's what we get out, is 1 squared plus a times 1 plus b. So 0 equals 1 plus a plus b. Somehow that thing equals 0. Interesting. What about the derivative of this thing? Can we find an expression for h prime of x? Well, we know a and b are constants, right? So we know how to take the derivative. The derivative will be 2x plus, well, whatever this constant would be. If it was 3x, it'd be 3, the derivative. If it was 5x, if it was negative 12x, it'd be negative 12. So plus a. And the derivative of the b is just going to disappear. So h prime of x is 2x plus a. And we know that h prime of x equals 4 when x equals 1. So 2 times 1 plus a. So 4 equals 2 plus a. Aha! A, try 2 on both sides, a equals 2. So I know something to plug back in here. If a equals 2, I know 0 equals 1 plus 2 plus b. So 0 equals 3 plus b. That means b must have equaled negative 3. So I have my two constants. Let's just check our work for a moment. That would mean that h of x would originally have been x squared plus ax, so plus 2x minus 3. H prime would have been 2x plus 2. And let's just check this work. H of x, if I plug in 1, I should get 0. So 1 squared plus 2 times 1, so plus 2, 3 minus 3. It does equal 0. And if I plug in 1 over here, I should get 2 times 1 plus 2 equals 4. That works out. So these are our two original functions, and here are our two values. That was kind of fun.